Welcome to this video guide on high tension or HT versus low tension or LT electrical systems. We will provide a complete point-by-point reference guide covering definitions, voltage levels, equipment, safety, applications, and more. This video is structured into 20 sections, beginning with fundamental definitions and standards. We will then dive deep into both HT and LT systems, cover key components, protection, safety rules, and applications before concluding with a side-by-side comparison and key takeaways. High tension, or HT, systems operate above 1000 volts AC, often called high voltage, or HV. They are used for long-distance bulk power transmission and are utilized by large industries and utilities. Low tension, or LT, systems operate at or below 1000 volts AC, serving standard domestic and light commercial needs. The Indian and IEC standards categorize voltage levels. Extra high voltage, or EHV, is above 220 kilovolts for grid transmission. High voltage, or HV, ranges from 66 to 220 kilovolts. Medium voltage, or MV, for industrial feeders spans 11 to 33 kilovolts. Low voltage, or LV, is 240 to 1000 volts, while extra low voltage, or ELV, is typically below 50 volts AC. Diving into the HT system, it manages loads above 100 kVA. Key equipment includes VCB circuit breakers, current and voltage transformers, and the trivector meter. HT consumers require a customer-owned substation and benefit from lower current and reduced transmission losses. The LT system serves smaller loads up to 100 kVA for domestic and light industrial uses. Protection relies on MCBs, MCCBs, and RCCBs. LT connections are simpler, supplied directly from the distribution transformer's low-tension feeder, often with no power factor surcharge. Key components for HT include circuit breakers, disconnect switches, current and voltage transformers, and HT power cables. For LT, common components are MCBs, MCCBs, RCCBs, kWh meters, and LT-grade PVC or XLPE cables for local distribution. Protection systems ensure faults are cleared quickly. HT utilizes complex relays like overcurrent, earth fault, differential, and distance relays, as well as the Buchholz relay for transformers. LT protection is simpler, with MCBs, MCCBs, and RCCBs protecting final circuits and people from earth leakage. Safety is paramount. HT rules require strict minimum clearances, mandatory permit-to-work systems, and specific personal protective equipment. LT safety focuses on using RCCBs in wet areas, maintaining earth continuity, correct cable color coding, and using a licensed electrician for permanent wiring. Power flows through various stages, stepping down the voltage incrementally from generation at 11 or 33 kilovolts up to the consumer level at 230 or 415 volts. High voltage minimizes transmission losses. The point of supply and metering methods differ significantly between HT and LT consumers. HT applications include large industrial plants, hospitals, railways, and irrigation schemes. LT serves residential colonies, commercial complexes, grid-tied solar rooftops, and Level 2 EV charging stations, illustrating the range of uses for each system. Here is a complete comparison. HT covers high voltage ranges and large loads, requires customer-owned substations, and mandates skilled staff. LT is for residential and small commercial use, involves utility-owned transformers, and has lower capital costs and safety risks. Earthing standards vary between systems. HT systems employ resistance or solid neutral earthing and require a minimum of 2 electrodes per transformer neutral. LT uses solid earthing systems like TNCS and TT, with RCCBs providing earth leakage protection for personal safety. Various electrode types are used to achieve the required earth resistance values. Metering is key for billing and power quality. HT uses a trivector meter to track kWh, kVA-RH, and kVA demand via CT/point. LT consumers use a simpler kWh meter. On-site instruments like clamp meters and power quality analyzers are vital for maintenance and troubleshooting. Installation standards rely on national and international regulations. IS 732 guides LT wiring, while IS 3043 covers earthing design. IE Rules 1956 and CEA Regulations 2010 provide the legal framework for electrical safety, particularly for HT consumers. Specific standards exist for transformers, switchgear, fuses, and cables. Comparing tariff structures, HT consumers face fixed and demand charges, an energy charge based on slabs, and surcharges for poor power factor. LT tariffs are typically per unit, tiered by consumption for domestic users, and include fixed monthly or demand charges for commercial and industrial users. Energy efficiency in HT involves power factor correction using APFC panels to avoid penalties. LT improvement is done at the distribution level or on individual motors. Energy savings can be achieved through VFDs, load shifting to off-peak hours, and using BEE-rated appliances and LED lighting. Maintenance practices vary by system. Daily HT tasks include visual inspection and SF6 pressure checks. Monthly HT checks involve insulator cleaning and lubrication. Annually, major maintenance includes circuit breaker testing, oil BDV tests, and relay calibration. LT maintenance is less complex, focusing on checking tripped MCBs daily. Monthly checks involve testing RCCBs and tightening terminals. Annually, LT maintenance includes insulation resistance tests, inspecting service cables, and checking earth connections. Troubleshooting addresses faults like HT cable insulation failure, HT transformer trips, and LT circuit dead faults. Actions range from isolating and repairing the HT fault using TDRs to resetting LT circuit breakers after identifying the cause through insulation resistance testing. Modern trends highlight smart grids, AMI for two-way communication, and SCADA for real-time control. Renewable energy integration includes solar, wind, and battery energy storage systems. EV charging, digitalization, and gas-insulated switchgear are also transforming electrical infrastructure. In summary, remember the 1000 V boundary separates HT and Lieutenant. Higher voltage drastically reduces losses. HT uses relays for protection, while LT relies on circuit breakers. Choosing between HT and LT depends mainly on the load size, and safety and standards must always be followed.